I think we understand, I understand anyway, slopes, but you should now get the idea. Let's do one more, a little more tricky, and we'll finish with it. Okay, so I have a slope here. I have a mass here. One mass. Two. Let's think. Okay. I'll think it as I draw this question. And let's say I have a force like that. And the M is M. And let's do numbers, okay. M equals to 10. Okay, let's put another mass. Also M equals to 10. And the angle alpha is 53.13. And there is mu static 0.5, mu kinetic 0.4. Let's do something different. Okay, the force is parallel to the surface, okay? Parallel to the surface. And let's give it numbers. Let's put, no, let's leave it like that. Let's leave it like this. Okay, first of all, let's draw forces and then we'll think what we can ask. So I'm drawing forces without the friction. So I have 100 newtons here, T there, T, normal force, 100 newtons, F, parallel to the surface. This is our axis. This is the alpha between the y and the mg. So I'm going to break it. But now let's see something new. I must break also the f. Why? Because it's also not on the axis. So if I want to break it, I must see what angle this is. Now this will be alpha because these two are corresponding, alternate angles. Alternate, forgot the name. I told you earlier. I wrote it something, just a minute. Alternate something, why don't I find it? Alternate interior angles. Okay, alternate interior angles. If you are not sure, I remind you again, instead of a square, just draw a dot. This is the F, this is the alpha. You see the letter Z here, like the letter Z? Always when you have the letter Z, these two are the equal, they are called alternate interior angles. So this alpha and this alpha are the same. And again, if you're not sure, draw it like a point and it will be easier to see. Okay, so I must break all the forces. Let's break. When I break the 100, it will break into this one and that one. This one will get the cosine. 100 cosine alpha is 100 cosine 53 is 60 newtons. And this will be 80 newtons. Now I'm going to break the F. The F, when I break it, it will be this way and that way. Who will get the cosine? This will get the cosine. So this will be F cosine alpha. F cosine alpha is F multiplied by 0.6. So it's 0.6 F, and this one will be 0.8 F. And I wipe it off. Okay. Okay, now this question is very sophisticated because the friction changes all the time. Why? Because if I change the F, what will happen? I will change this force, and this force will change the normal force, and the normal force will change the friction force. So the F affects the friction. So the question is more complicated. So let's see what we can ask. Let's start by asking question 1. Let's say F is first of all, what is the F minimum? Let's ask this one. In order for this mass to stay on the slope, F minimum in order for M, how do I write it? M stays on the slope. Let's start with this question. What is the minimum force I can apply that this mass won't go up the air? So what I must ask is that the 0.8 F must be smaller than 60, because if it's more than 60, what will happen to the mass? It will go up, because if this force is bigger than that force, it will go up. If it's smaller than that, the M will adjust itself in order for this mass not to move. Because M can adjust itself, it's similar to the friction in the idea, to the maximum friction. It's similar, but it's not the same. Normal force always can adjust itself up to a point when this force is bigger than this force. Just for example, say I'm 80 kilograms and 800 newtons is my mg. If I'm pulled back up by 700 newtons, I will not go up yet, and the normal will adjust itself, it will be 100. If I'm pulled up by 900 newtons, I will go up, so there will be no normal force, and I will accelerate. Like this here. If this one is bigger than that one, it will go up and there will not be any normal force. If this one is smaller than that one, it will stay on the slope and the normal will adjust itself. And so what I will ask it to be equal, because I want the minimum, to be equal to 60 newtons. So F minimum will be 60 over 0.8, which is a big problem because I don't have my calculator. But anyway, this is the minimum force. It's around 65, 70, something like that. Let's see if I can do it without my calculator. It's 60. This is like 8 over 10 or 4 over 5. And if I multiply it 5 over 4, it's 60 over 4 is 15. Multiplied by, it's 75, I think. Again, 60, 8 over 10 is 600 over 8 is 300 over 4. Yes, it's 75, I think. 150 over 2. Okay, it's 75. So, the no calculator cost me, I think, 40 mega now. And I don't know what to do about it. Anyway. So, I know that if F is 75 newtons and more, this mass will go up. If it's less, it will stay on the ground. So, second question. I want to know what will happen if F equals to, let's just say, less than that, of course, 10 newtons. I want to know what will happen to the system. Okay, I want to know if it will accelerate, if it will accelerate which way, if not, why not, everything. Okay, let's start calculating. If F is 10, so what will I write? All the forces in this direction are 80 plus 0.6 plus 10. 0.6 plus 10 is 6. All the forces in this direction is 100. So obviously 100 is bigger. So if 100 is bigger, it means the tendency to move will be that way. And if the tendency to move will be that way, I'm applying one more force, the friction force, this way. Now I need to know if the 100 can overcome not only the 86, but also the biggest friction there is. So let's calculate the F static max. It's mu statics multiplied by n. Mu static is 0.5. Now what is n? Multiplied by n. Let's calculate n for a second. So I'm writing n. I know that n plus 0.8 multiplied by f, which is 0.8 multiplied by 10, which is 8, must be equal to 60 because it doesn't go up nor down according to the first law of Newton. They are equal. So the normal force will be 52. So it will be 0.5 multiplied by 52, which is 26 newtons. So now I'll ask the question. This way I have 100 newton. This way I have 86. And the maximum friction force can be 26. So does the 100 overcome the 80 plus the 6 plus the 26? No, it doesn't. It's smaller. So what will happen to the system? It won't accelerate, zero acceleration, and the friction force must adjust itself in order for the system to apply the first law of Newton, because it doesn't move. So if I have 100 here and 86 here, the friction force must be 14 to adjust itself, so it will be 100 here and 100 there. So now I know what happens to when f equals to 10. What happens if f equals to another number? I have to again do all this checking. First of all the tendency, then to put the friction, and then to see if it overcomes the friction. Okay, let's see what happens when f is 75. 75 newtons. 75, it will be harder for me because I don't have my calculator. It will be harder for me. So we leave it like that. It's enough. Okay, but the idea is that f, you can see it here, f changes the normal changes the friction, and the friction, and with this friction I go and check if the system moves or doesn't move. So you know what, let's do another one. Okay, let's do one just with letters, so it will be easy for me because, as I told you, I didn't bring my calculator. Okay, this alpha, let's say this is f, and this is m. And I have mu static equals to mu kinetic, which equals to mu. Okay. And I want to know what is the... and one more thing I want to tell you. This is a summary question. It's a little hard, but let's do it. I add an information to this drawing that tangent alpha is smaller than mu. What does it mean that tangent alpha, no, it's bigger than mu, it's bigger than mu. It's bigger than mu. What does it mean that tangent alpha is bigger than mu? If you look few minutes earlier, not so few, but minutes earlier, it means that if there is no force at all, the alpha is bigger than the alpha minimum I need in order for this mass to move down. So this mass will go down. It overcomes the biggest friction that can be without the F. With the F it's another question, but without the F it will overcome the biggest friction and it will fall. So it means that if F equals 0, this F, the mass will slide down. This is what it means. Okay, now the question is this. What is the range of F in order for this mass not to move? M doesn't move. This is the question. What range can I use this F and the mass won't move? Obviously, if I don't have a force here, it will move. So it must be bigger than 0, but it must be also smaller than something. Let's find everything. So first of all, I remind you, I draw forces without the friction. And I will tell you another thing. Vector, I remind you, we can move it. So instead of drawing it like that, it's better to look at it like this. It's easier for us to calculate things. So just move it instead of pulling and pushing, pulling. It's the same. Okay, we have mg. We have the normal force. And now, and of course, we have this axe. And I must break vectors into its components. So this is the alpha. This is 90 minus alpha. This will be also alpha. So I must break two vectors here. Let's break them. If I break the mg, I will get, that's it. I will get mg cosine alpha, mg sine alpha, and if I break the f, I will get f, this one will get the cosine, f cosine alpha, f sine alpha, and I wipe it off, Again, notice that the f affects the normal force, and the normal force affects the friction force, so it's complicated. But in this case, there is no F force which will make this mass go up, because it just helps to press it to the slope. So the normal force will be just bigger and bigger and bigger, and the friction force will be bigger and bigger and bigger as this F grows. Okay, so the question, if this mass can lift from the slope, is irrelevant here. Okay, so let's start to answer the question. Now, there are two things I need to know about this question. Here I have F minimum I need, and here I have F maximum. What can I say about the F minimum? Let's calculate the F minimum first. The F minimum means that if I do a F minimum, we said that the system will not move. F minimum means that it will not move that way. And F maximum means that it won't move that way. This is the idea of this question. So because we know that if F is 0, for example, if there is no F at all, obviously it will go this way. So I want the F minimum I need in order for it not to move that way. So if the tendency is to move that way, I'm applying the friction force this way. Let's calculate the friction force, the F static max. F static max is mu static, which is mu, multiplied by the normal force. So it's mu multiplied. The normal force equals to that plus that, because in this axe, it doesn't go up nor down. So according to the first law of Newton, it will be F sine alpha plus mg cosine alpha. This is the F max, and F affects it. This force affects it, so it's complicated. So what will I ask? I'll ask that the mg sine alpha, which is the force in this direction, I want it to be, I want the system, sorry, we said the F minimum, we said I don't want it to move. So that if I don't want it to move, I want this force to be equal to these forces. So I want it to be equal to F cosine alpha plus the friction force, but the maximum friction force, which is this one, plus mu F sine alpha plus mg cosine alpha. This is the condition to find the F minimum. Again, I'm explaining it again. F minimum means the minimum force I need in order for this system not to move downwards. If I'm talking downwards, means that the friction will be this way. And if I don't want it to move, I'm asking that these forces will be equal to these forces. Now if I want the extreme force, the minimum is extreme, I'm using the extreme friction force. Always when you are asked to find extreme forces, minimum or maximum, it doesn't matter, use the F static max. So let's find F minimum from here. So I'm writing mg sine alpha equals to F cosine alpha plus mu F sine alpha plus mu mg cosine alpha. Now I'm moving this one there, so F cosine alpha plus mu sine alpha equals to mg sine alpha minus mu mg cosine alpha, and I'm going to divide it, so F equals to, and I'm going to pull out mg, so it's sine alpha minus mu cosine alpha divided by cosine alpha plus mu sine alpha. Okay, I think we'll say goodbye to this pen. Okay, this is the F minimum, also to this one. This is the F minimum I need in order for this system not to move downwards. Now let's try to find the F maximum. Let's do it. Goodbye to this one too. What happens here? No pens? Okay. A new pen. Beautiful. Okay, so now I want to find the F max. The F max means that if I pull a little more, it will start moving that way, because it's maximum that way. So if it will move that way, the friction will obviously be this way. Now it's the same calculations, but the idea is different, because the tendency is to move that way. So what will I ask now? I will ask that F cosine alpha, which is the forces on this direction, will be equal to mg sine alpha plus the friction, the maximum friction that can be. Let's solve it. F cosine alpha equals to mg sine alpha plus mu, I'm opening the brackets here, mu F sine alpha plus mu mg cosine alpha. Now I'm moving this one there and I'm pulling the F out, so it's cosine alpha minus mu sine alpha equals to, I'm pulling mg out here, so it will be sine alpha plus mu cosine alpha. So F will be, F max will be mg sine alpha plus mu cosine alpha over cosine alpha minus mu sine alpha. So now I can conclude and say, if F is between this one, mg sine alpha minus mu cosine alpha over cosine alpha plus mu sine alpha, and this one, mg sine alpha plus mu cosine alpha over cosine alpha minus mu sine alpha, if F is between these two, whatever these values are, the mass won't move, and the tendency changes. When I apply this force, the tendency will be there, and if I apply this force, the tendency will be there. Okay, and very important, this, because if I didn't say that, if I would say that tangent alpha is smaller than mu, it means that even if there is no force at all, it won't move downwards. So F minimum will be automatically 0. So the answer will be from between 0 to this value. Okay, this question is a little harder, but it's a very good one. Okay, so I thank you very much. We finished dealing with forces now. Next lesson we're starting to dealing with kinematics. Looking forward to do it. Thank you.